Hello everyone, today we will solve some problems which are based on potential energy, and these type of problems are asked in CSIR NET, GATE and IIT JAM exams. The first type of the problem is you have to find the position of stable and unstable point in potential energy and position curve. You know that for equilibrium of a system, net force is 0. If net force is 0, then we can write it in terms of the potential energy, and you know that it will be equal to minus del V over del X. And if the system is in equilibrium, then we can write it as equal to 0. Here you have to note that the potential energy is a function of the position coordinates only. Now if you have a potential energy and position curve like this, it is a potential energy and position curve. Let us say it is x-axis and it is y-axis. We are taking on y-axis the potential energy, and on x-axis we are taking position. Let us say our curve is like that, and let us say this is the A position of the curve, and it is the B position, it is the C position, it is D position, and it is E position. Here you see that the points A, B, C, D and E are parallel to x-axis. So we can write here for these points del V over del X equal to 0. So it means that A, B, C, D and E are the points where stable or unstable equilibrium condition will exist. Right? Now we have to investigate the condition of the stable and unstable equilibrium positions. Now number 1, stable equilibrium. First I will draw a graph for stable equilibrium between the potential energy and position. Right, let us say your graph is it is U-shaped graph actually, and and let us say it is a point where we have to investigate the condition of a stable or unstable equilibrium. Here from this position, if a particle is displaced through a very slight force, and if this point acquire after removing the slight force its initial position, then it is called as the stable equilibrium. Suppose the particle, after applying a slight force, first goes to the right side, and then it comes to its initial position, and let us say then the particle comes to the left side here, and after reaching this position here, it comes again to its initial position. So this is the situation of the stable equilibrium. If this type of problem is asked, then first you can see here that your potential energy it is a function of x and it is minimum, right? Here your potential energy will be minimum. Then you have to find del V over del X. In the second step, you will put del V over del X equal to 0, and from here find points. When you find the points, then find del 2V over del X2. If del 2V over del X2 is positive, for points, then it will be a stable equilibrium condition. Means here first you will be in this type of problem, a potential energy will be given in terms of the position coordinates. Then you will find del V over del X, then you will put del V over del X equal to 0. From using this condition you will find the points. When you find the points, then you again will find del 2V over del X2, and what points you have find here, you will put the value of those points in the relation which you have obtained for del 2V over del X2. If this del 2V over del X2 is positive, then the condition will be a stable equilibrium. Now number 2 is unstable equilibrium condition. It can be understood by a graph between potential energy and position again. Let us say your graph is like this, and this is your C point. If a particle is or a system is displaced through a small force in right direction, and after doing that force, if the particle is not come to its initial position, then it will be an unstable equilibrium condition. Similarly for the left side, so when a particle is actually permanently removed from its initial position, then the condition is called as the unstable equilibrium condition. You can understand it like suppose the particle is displaced up to this position from here, and if it does not come to its initial position, then we will say that it is permanently displaced. Similarly, for left side, we can say that it is permanently moved from its initial position, right? It is the initial position of the system. Unstable equilibrium condition, first you will have a relation like V is equal to Vx, means your potential energy will be given in terms of the position coordinates. Then you have to find del V over del x, right? Then you have to put del V over del x is equal to 0, and from here you have to find the points. Find points here. You have to find del 2V over del x2. Okay, now if del 2V over del x2 is negative for points which you have obtained by putting the condition del V over del x equal to 0, then it will be a condition of the unstable equilibrium. Right? Or in briefly we can say that in these type of problems your potential energy will be given in terms of the x coordinates or position coordinates. Then you will find del V over del x, and in the third step you will put del V over del x equal to 0. From here you will find the points, and then you will find del 2V over del x2. Now if your del 2V over del x2 at these points is positive, then it will be a condition of stable equilibrium, and if del 2V over del x2 is negative, then it will be a condition of the unstable equilibrium. Now we will take some numerical problems by which you can easily understand what we have explained till now. Now let us take the first problem, and it is here your potential energy it is given like Vx is equal to 1 by 2 kx square minus lambda by 3 x cube, right? Here your k and lambda are positive constants. You have to find here the position of unstable and stable points. So first we will find the value of del V over del x. If we differentiate it with respect to x, then you will write it like 1 by 2 k into 2x minus lambda by 3 into 3x square. Okay, so it becomes here your del V over del x is equal to it is kx minus lambda x square. right? We will put here, the next step is will be our del v over del x equal to 0. So we will put kx minus lambda x square is equal to 0. So here you will find x k minus lambda x is equal to 0, or here you will find 2 points. One will be x equal to 0 and other will be x equal to k upon lambda. Now you have find the points. See here, your first step was that your potential energy is given in terms of the position coordinates. Then you find del v over del x. Then we put del v over del x equal to 0. From here we have find the points if we put del v over del x equal to 0. Now we will find the value of del 2v over del x2, and we will investigate that value at x equal to 0 and x equal to k upon lambda. First we will find the value of del 2v over del x2. It is equal to, that was your earlier relation, your del v over del x was equal to, it was equal to kx minus lambda x square, right? So here del 2v over del x2 will be equal to k minus 2 lambda x. Now your first point was x equal to 0. Now when we write x equal to 0, then you see that del 2v over del x2 is equal to k in this relation, and because you know that k is greater than 0, it is given already, so it will be a positive. That means at x equal to 0 the condition will be a stable equilibrium. Now at x equal to k upon lambda, if we put this value x equal to k upon lambda here, then we will see that your del 2v over del x2 is equal to, it will be k minus 2 lambda into k upon lambda. So it becomes minus k, because k is positive, so it will be a negative value. It means here your del 2v over del x2 is negative. So at point x equal to k upon lambda, it will give you unstable equilibrium condition, right? Example number 2. Let us say your potential energy function Vx is equal to it is x cube minus 4x square plus 4x. Here you must understand that whatever the constants are written with x, they are the known constants. It is not like our earlier problem where k and lambda were the unknown constants. So we can find here the position of the points, and that will be like here Vx is equal to, if I take x common here, then I can write it as x square minus 4x plus 4, right? Or it will be equal to x minus 2 whole square. So here there will be 2 points for which you have to investigate the condition of stable and unstable equilibrium, right? Those will be we can write x is equal to 0 and other will be x equal to 2. Now we will find the value of del v over del x. So del v over del x will be it will be 3x square minus 8x plus 4, and del 2v over del x2 will be equal to, it can be written as 6x minus 8, right? Now your points were x equal to 0. At x equal to 0, what is your del 2v over del x2? Your del 2v over del x2 here, it is negative value. It will be 6 into 0 minus 8, so it comes out to be minus 8 or negative. So at x equal to 0 will be unstable equilibrium point. Now the other point is x equal to 2. At x equal to 2, del 2v over del x2 is equal to, here if we put here the value of x equal to 2, so it becomes 6 into 2 minus 8, it comes out to be 4, and it is a positive value. Okay, so at x equal to 2, the system will have the stable equilibrium, right? Now the other problem which you can solve, and that is like you have to solve it yourself. Vx is equal to ax minus bx cube, where a and b are constants and greater than 0, or a and b are positive constants. So you have to investigate the condition of the stable and unstable equilibrium. Then we will discuss in next video the second and third type problems, which are also very useful for the especially for CSIR NET exam and IIT JAM exam. Thank you.